I have something I want to show you. I bought this graphics card used on eBay, and thanks to tons of great work by CoreForge over on GitHub, this graphics card now works almost completely on the Raspberry Pi 5, with a few caveats, but way less than we had with the Compute Module 4. This setup is something that you can't really replicate exactly yet. I'm sorry about that. I'm using this little thing called the uPCity or uPCity or something like that. This is from Pineberry Pi, the guys who also make the little NVMe hat. But this is the graphics card. It's in a PCI by 16 slot that is adapted. Oh man, you really can't see anything here. Sorry about that. But it's adapted using that little flat flex connector into the Raspberry Pi's, the Pi 5's PCI Express slot. That's in here. There's a power supply powering the graphics card through its own PCI power connection. It's also powering this board because this has to carry up to 75 watts for the card. And then the Pi is powered by this guy, the Raspberry Pi 5 power supply. And then I also have a fan plugged in, kind of blowing air over this, because I noticed that the fans don't come on this thing and it gets kind of hot, and I haven't repasted it, so I don't know if the thermal paste in this thing is still any good. It was in pretty good condition for being a used card. Also, this, for if you're wondering, this was in my last video. It's a BleeCube Mini KVM, what is it called? The BleeCube V4. The reason I'm using it is because this week is crazy. We got our final inspections at the new studio and office. I have the final electrical inspection. I'm working on the business license. I'm starting to move some things in. Some things are getting shipped there. And of course, this is my desk right now. So I have two other videos I'm editing right now, but I wanted to show you this before I tear this all down and start moving over there, because it works. And you wouldn't know that because right now, for some reason, BleeKVM is not showing it on here, but I have it passing through the HDMI signal here, and this is the console. So you can see that's the console. I don't have room for another keyboard and mouse right now, but if I run through here, what is it? Wayfire Pi. Run that, it should launch the Wayfire environment. There it is. And this is running on the graphics card. So you can see it's plugged into the HDMI output here. There's nothing plugged into the Pi's HDMI output. Editor's note, there was something plugged into the Pi's HDMI output, but it was this adapter that I had been using earlier. That's just me on a day when I've been at the office moving things and putting together shelves and that kind of stuff. So sorry about that. And this all works, and it's really hard to control because I'm kind of like blindly clicking on things. Here's the Pi menu, and if I go to Chromium, YouTube, so this is all rendering through the graphics card. Now the pass-through for Chromium to the GPU is not working at this time. There's a lot of little things that will need to be worked on. BleeKVM is killing me here. It is so hard to use this blind. I could just plug you know what, I'm gonna go plug a mouse into the Pi. Hold on a second. Okay, so I got a mouse and a keyboard here, and I just realized it's not BleeKVM. BleeKVM is having issues with displaying the display output, but the mouse is actually disappearing here too. So you can see the mouse is not here. That's annoying, but it's livable. We can figure this out. Let's go using the keyboard to the terminal. And if I run GL Mark 2, I want to move this up almost. Oh, nope. Nope. There we go. Okay. GL Mark 2. I'm going to run this, and you can see it's all rendering on the graphics card. So this output is going through here, and you probably can't hear that because the microphone is not that sensitive here, but you can hear different coil line sounds coming through the card. So you know it's actually doing some hard work. You can actually check that. So you can see there's 2,642 frames per second. It sometimes locks up here. So I'm going to open up another terminal window, and we'll run Radeon Top. Radeon Top shows us what's going on the graphics card itself as it's rendering all this stuff. So let me try to move this out of the way. So you can see as it's rendering things, the graphics card's getting used. And there are some issues still that we're working through. The message. You can see that there's all these faulting instructions that are being fixed. This is a problem with a lot of different ARM64 drivers. So this is an older card. This thing was what, I don't know, 2015, 2016? I don't know. Is there a date on here? Yeah, 2016. So this card was out in 2016. That was before, like, that was back when ARM processors were like only mobile phones and Newton. Well, the Newton was old by then, but you get the idea. This is an oldish graphics card, even though it was born after some of my children. But anyway, this is an oldish graphics card, and it has some issues, but it is rendering a lot faster already than the built-in graphics on the Raspberry Pi 5. This is cool because there's a lot of possibilities that are unlocked when you can use an external graphics card on a Raspberry Pi. That's something you can't do on a Mac. You can buy a Mac Studio down here. I mean, look at this thing. This thing was like, what, $3,000 or something. This little $60 Raspberry Pi 5 can do something it can't. So far, we're getting some AMD stuff working. We might be able to get other newer cards like this guy working. I actually got a little bit of ways through it, but there's a lot of little memory issues that are not really the Pi's fault. It's just the driver expects a lot of things to be x86 specific, but here. This is still running. Instructions for setting all this stuff up, everything that I've done are on GitHub, but you can see here it looks like we've hit a point where it's locked up and it's just spitting out tons of errors. It might get out of this at some point, but it isn't yet, and I haven't been able to run through a whole OpenGL instance, but you can see all the scores here. Way faster than the Pi's own built-in graphics. I wish I could spend all day working on this, but I just have too many other things that I'm doing right now, trying to get everything moved into the new space in the next week or two. But I wanted to post this so that A, you can see that we have this working. This has been years of work now trying to get this all working. And B, if you're interested in testing this yourself, right now there's no easy way to adapt, but if you buy one of the Pineberry M.2 adapters, you can get M.2 to PCI Express and then do that kind of thing, and have a bunch of adapters. Or hopefully, I'm asking Pineberry and any other developers to release boards that allow you to adapt the Pi 5 to a standard PCI Express card slot. There are a lot of people arguing right now about whether the Raspberry Pi 5 is a true potential desktop replacement type of computer. And I mean, if you use external graphics like this and you have certain use cases, it could be. It could replace some uses more so than it could in the past. And I'm excited because as more people get into this, I think the ARM drivers for all these different graphics cards are going to get better, to the point where the Ampere system that I've been testing, that'll get better. The Rockchip boards, some of those bugs that affect them will get better. So it's really cool to see this, and I'm so thankful to everybody who's helped through the past 3 years now, from AMD, from the open source community, CoreForge, Elfardo, and all the other people who've helped in the GitHub issues. And please, like I said, go check out that if you're interested in how this is done. Yes, it involves rebuilding the kernel, and yes, I have a t-shirt for that. And yes, Christmas is coming up, and you might be wondering why there's an X-ray of a Raspberry Pi right there. Don't worry, a video will come out on that soon, but there's also a shirt for that too. So until next time, I'm Jeff Geerling.